So this is our project. We have implemented the two algorithms using the algorithm using two methods. One is the divide and conquer, another the brute force. Let's just go with the code. Here we have just imported the important functions and all the modules. Then we have a random seed method to randomly reproduce the seeds for us. And then we have a function here for the closest method where we just use a square formula to calculate distances and compute the minimum distance here. And then we have the divide and conquer method for to get the closest distance where we just use the divide method to divide it by left and right and just pick up the closest pair, dividing and just splitting. And then we have the brute force for small cases as well, which is the best case, like if n is less than 3. And then we have a function for the closest split pair to be produced. Here we are using the sorted lambda function to pick up the shortest distance here, using the obviously the shortest is to be under square method as well. Then we have a method for generating distinct points, which we have a max attempt to prevent infinite loop. Then we have a while function with the obvious condition here. Then we are getting the range here and have the point sets are less than the n, then we could not generate n decimal points. And if yes, then we just return the list, and we have a function here to verify the algorithm. Then we have the function to run the experiments. Obviously, we have input size to 100K, but we are using the alternative smaller size up to 55,000. And we have n is equal to 10. We have results to store the results to algorithm times, algorithms average time for both the algorithms. Then we have the for loop to run the command for us and to print all the iterations for each of the input sizes. And we have to store the results here, algorithm and algorithm 2, and we print out the averages and just return the results. And here is the function to calculate the constants in the table. We use the average function result and just use the empirical formula, which is just getting the ratio here, and we just use the max of these ratios to give it to the constant. And same for the algorithm 2, then we just return the constants and the ratios, and then we generate the predictions using these two formulas for the algorithms, as we are using the time complexity of each of the algorithms to get the prediction, generate the predictions here. And we have a function to plot the graphs here. First graph would be empirical running time comparison, and then it would be algorithm empirical versus predictable, and I'll go to empirical versus predicted and just get the output graph there itself. And here's the main function which is running all the I can say all the functions that we have defined above. So if we just run them all through, then we just get the then you just get the idea here. And we have also the verifying algorithm for small input, as we have input generated a distinct input for the range 0 to 100, and it verifies for the same results as well.